Assalamualaikum warahmatullahi wabarakatuh. Good morning, esteemed guests and fellow researchers. Today we are excited to present our finding on the sentiment analysis of electric vehicle among the community on social media X. Our team, comprising me as Hafiza and Aka Putri Adamansyah, has employed the naive bias and decision tree method to delve into the public perception and attitudes toward electric vehicles. We believe our research offered a valuable insight into consumer and sentiment, which is crucial for advancement of sustainability transportation. Okay, the first one is the background. Electric vehicle technology or EV has become an important innovation in the global automotive industry, along with the growing environment awareness and the need to reduce carbon emission. Many countries, including Indonesia, are encouraging the adoption of electric vehicle. Electric vehicles are not only have a positive impact on the environment, but they also offer better energy efficiency and potential saving and operating costs. Although the government has provided various incentives and policy to encourage the use of electric vehicles, the adoption of this technology still face challenges. One of the determining factor for the success of EV adoption is public perception and sentiment toward this technology. Social media acts as the main communication platform today plays an important role in the shaping and reflecting public opinion. Social media X or Twitter is a rich source of data to understand people's view on various topics, including electric vehicle or EV. Sentiment analysis is an effective method to explore people view and feeling on a topic using text data from social media X. Sentiment analysis from social media data X can provide insight into public acceptance of EV. This technique involves using natural language processing (NLP) algorithm to identify and classify opinion as positive, negative, or neutral. The naive Bayes algorithm, which is use the principal probability to classify text based on the word that appear in it. It's one of the popular and simple algorithm in sentiment analysis. Therefore, the purpose of this study is to conduct sentiment analysis on electric vehicle in the community on social media X using the naive Bayes algorithm. This research is expected to provide deeper insight into public perception of EV and the factors that affect this sentiment. EV are emerging as an innovative solution to overcome dependence on fossil fuels and reduce greenhouse gas emission. The transition to EV is expected to support sustainability energy policy and meet global emission reduction target. The application of this method to social media data will help identify trend and pattern on public sentiment toward EVs. This study is supported by various previous studies that have applied naive bias in EV sentiment analysis. This study provides a methodological and theoretical basis for further analysis. This research aims to deeply understand public sentiment toward EV and their implication for future sustainable transportation policies. In addition to the naive bias algorithm, the decision tree algorithm is also often used in sentiment analysis and various other machine learning applications. The decision tree algorithm builds a prediction model based on the value of data attributes. This model uses a tree structure or rule-based structure to represent all possible decision-making scenarios. The decision tree algorithm has several advantages, such as ease interpretation and the ability to handle categorical and numerical data. In addition, decision tree can also handle classification and regression issues. In the context of electric vehicle, the decision tree algorithm can be used to identify the factor that most influence the positive, negative, and neutral sentiment of the community. For example, we can use a decision tree to find out if tweet that include certain word or from user with certain characteristic are most likely to have positive, negative, and neutral sentiment. For the next is Eka Putri Ramansyah.
Okay, next, problem formulation. Number one, what is the public sentiment toward electric vehicles in the community on social media X? And next, what are the factors that affect public sentiment toward electric vehicles? And how accurate are naive Bayes and decision trees method in this classifying public sentiment about electric vehicles on social media X? And the purpose, number one, analyzing public sentiment toward electric vehicles in the community on social media X using the naive Bayes and decision tree method. And next, identify factors that affect public sentiment toward electric vehicles. And next, measuring the accuracy of the naive Bayes and decision tree method in sentiment analysis for electric vehicles on social media X. And research benefits. Number one, provide a better understanding of public perception and sentiments toward electric vehicles. And next, provide insight for electric vehicles manufacturers and policy makers and on how society responds to electric vehicles. And three, assist in the development of more effective marketing strategies and policies for electric vehicles based on public sentiment. Next stage, let's take a closer look at the stage of our analysis. First, we have data collecting to pre-processing data, to labeling, to naive Bayes classification and decision tree, to evaluation. And number one, data collecting. The data used in the study is raw data obtained from social media X, Twitter. The data set was collected through scraping techniques using the tweet harvest library in the Python programming language. The crawling process requires an auth token from Twitter and collect data of 3,408 tweets. The keywords used to search for relevant tweets are electric vehicles, electric cars, electric motorcycles, electric bikes, and electric bus. In addition, an Indonesian filter length ID is applied so that the data produced is in accordance with the needs of the research. Here is the electric vehicles data from X Twitter. And next, number two, data preprocessing. After getting the raw data, the next step is data preprocessing. Data preprocessing is an important step in sentiment analysis to ensure the data is ready to be used from further processing or analysis. This stage is the processing of raw data into clean data. The following are the stage: cleaning data and case folding. In the data cleaning stage, sentence of tweets in the form of user text at symbols, numbers, and URL links will be cleaned. And in the case folding stage, the sentence of the tweet will be equalized and change all capital letters to lowercase because not all text is consistent in the use of word letters. Here are the result. This. Okay, next, tokenize. The next stage of tokenizing is process that function to break down a sentence or paragraph into individual words or tokens. This stage uses the Python command split to separate each word with a comma. Here are the results of the tokenizing stage. This is the image. Next, stop word and stop word. Okay, next, uh, um, we have, wait, stemming. The stemming process refers to changing words into their basic form by removing exciting suffix. In the content, we use the Sastrawi library to do the stemming process. Okay, next, labeling. At this stage, the dataset is categorized into 3 labels, namely positive, neutral, and negative. The process of determining this label is carried out through the polarity function will produce a value of minus 0,5 and close to 0,5 can produce positive polarity, while polarity 0,5 will produce a neutral value and close to um, 0 minus 0,5 will produce negative. Contained in a comment on Twitter with a positive tweet result of 8,04%, negative tweets of 6,55%, and neutral tweet of 85,41%. Here are the results of the stage. Okay, next, Fiza.
Okay, this is the labeling of positive, negative, and neutral sentiment that in a bar chart. Okay, this is the evaluation of the classification. So in this study, two classification algorithm, namely naive Bayes and decision tree, were successfully applied to conduct sentiment analysis on electric vehicle in the community on social media X. By using the two type of feature, namely Bigram factor and Bigram TF-EDF, IDF, researchers have trained the model and obtained quite a good result. The naive Bayes model, despite having a relatively low recall and um, F1 score value, show potential in classifying public sentiment toward electric vehicle. This suggests that there is a room for improvement, especially in identifying negative sentiment. On the other hand, the decision tree model show excellent performance in identifying positive and negative sentiment. High value of accuracy, precision, recall, and F1 score indicate the effectiveness of this model. In the comparison between the two models, the decision tree model performed better than Naive Bayes model in terms of all evaluation metric. However, it's important to remember that model performance can vary depending on the dataset and experiment setup. Therefore, cross-validation and parameter adjust are important steps to ensure that the model provides the best performance. In addition, while decision tree provide better performance, Naive Bayes has an advantage in terms of computationally efficiency and ease of interpretation. Therefore, the choice of model should be based on consideration between performance, efficiency, and interpretability. Okay, the result and the discussion. The Naive Bayes model with the Brigham factor feature, the Naive Bayes model achieved an accuracy 0.863, a precision of 0.633, a recall of 0.577, and F1 score of 0.595. Meanwhile, with the Bigram TF IDF feature, the model achieved an accuracy of 0.860, precision of 0.597, a recall of 0.361, and F1 score of 0.359. This result show that Naive Bayes model is able to classify public sentiment toward electric vehicle quite well. However, the relatively low recall and F1 score values suggest that the model still has room for improvement, especially in identifying negative sentiment. The decision tree model with the Brigham factor feature, the decision tree model achieved an accuracy of 0.935, a precision of 0.855, a recall of 0.750, and an F1 score of 0.807. With the TF-IDF Bigram feature, the model achieved an accuracy 0.933, precision of 0.926, recall of 0.725, and an F1 score of 0.766. These results show that the decision tree model is able to classify public sentiment toward EV very well. The high value of accuracy, precision, recall, and F1 score indicate that this model is effective in identifying positive and negative sentiment. Model comparison. From the result above, it can be seen that the decision tree model provides better performance than the Naive Bayes model in terms of evaluation metric. This suggests that decision tree may be better suited for the sentiment analysis task than Naive Bayes. Keep in mind the model performance may vary depending on the dataset and experiment setup. Therefore, it is important to always perform cross-validation and parameter adjustment to ensure that the model provides the best possible performance. In addition, while decision tree provides better performance, Naive Bayes has an advantage in terms of computationally efficiency, and ease of interpretation. Therefore, the choice of model should be based on consideration between performance, efficiency, and interpretability. Overall, the study showed that sentiment using machine learning method can provide valuable insight into people perception of EV. This result can provide a better, better understanding of public perception and sentiment toward electric vehicle. Okay, in conclusion, or our analysis using the Naive Bayes method and decision tree has been provided us with nuanced understanding of the community sentiment toward EV on social media X. We have uncovered valuable pattern and insight that can inform stakeholder and shape future strategy in the EV industry. We could like express our sincere gratitude for your attention and engagement throughout our presentation. Wassalamualaikum warahmatullahi wabarakatuh.